Okay, so our next question. We have a function, f of x is equal to 3 times 16 to the 3/4 x. I'm guessing that's what that says. It's a little hard to see. And we have 6 statements, and we want to see if all of these are true or not. So we're going to go through each statement one by one. So our first statement is the initial value is 3. So the initial value being 3 basically means that f of 0 is equal to 3. So we need to prove this. If this is true, then the statement is correct. So by plugging in 0 into this equation, we get 3 times 16 to the 3/4 times 0, which is just the 0, right? Because any number times 0 is 0. Now, whenever you have any sort of number raised to the 0 power, so any number a raised to the 0 power, that's always 1. So we know that this term is equal to 1. So it would just be 3 times 1, which is 3. So f of 0, the initial value of f is equal to 3. So this is correct. All right. Our next statement. The initial value is 48. So since we already found that the initial value is 3, right? So we know that it's 3, then that implies that it's not 48, right? So that would be incorrect. Okay? And now we have the next statement. The domain is x greater than 0. So this statement is incorrect, and I'll explain why. So the domain is all x such that f of x exists, right? So all values of x where you get a defined value in the function. So to prove this case wrong, that the domain is greater than 0, let's plug in, for example, -1, right? So if we evaluate the function at -1, we get 3 times 16 to the -3/4 power, right? This is still a defined function because I believe it would be 3 over 8 because you would just do the 4th root of 16, which is 2, raised to the 3rd is 8, negative power, so it's 1 over 8. 3 times 1 over 8 is 3 over 8. So because the function is still defined and you are allowed to take negative exponents, right? Negative exponents are a thing. They give you defined numbers. So for that reason, the statement is incorrect because you can take basically any number and you can raise it 16 to that power and you will still get a defined number, even 0, as we did in the first statement. So this one is incorrect. Okay. And now we look at the range. So the range is y greater than 0. So how do we tell that the range is y greater than 0? So again, the range is all values of y basically. So the values that y spans, right? So when you look at the values that y span, as you plug in any x value, there's one thing that they all have in common. So f of x is equal to 3 to the 16 times 3/4 to the x. So for any value of x, for any exponent that this takes right here, this entire term will always be positive, no matter what, right? Because what's inside, what the base is right here is positive. The exponent of any positive number raised to an exponent is still positive. And multiplied by this positive number will also still be positive. So y will always be positive, that's known for a fact. And y will also never be 0, because this number is non-zero, this 3 coefficient, and this, you can never raise any base to an exponent and get 0. So this will never be 0. So for that reason, we can conclude that f of x is always going to be greater than 0, meaning that our statement is correct. Okay? So now we have statement E. Statement E says the simplified base is 12. Statement F and E actually go hand in hand, right? So we're looking for the simplified base. So to simplify the base, what we can do is look at the base that we're simplifying. So 16 to the 3/4 x, right? And we want to simplify this base as best as we can. We can use properties of exponents, and we can say that this is the same thing as 16 to the 3/4 to the x power, because whenever you raise an exponent to an exponent, you end up multiplying them, and 3/4 and x in this case are a product. So now we just evaluate 16 to the 3/4, and whenever you have a fraction exponent, what you do is you take the fourth root of, so the denominator acts as your nth root. So an n denominator gives you an nth root of your base. So you would take the fourth root of 16, and then your numerator would be the exponent. So to the third power, and then this entire thing raised to the x power. And now we have to ask ourselves what number, when you raise it to the fourth power, gives you 16. Pretty quickly you can come up with the number 2. So the fourth root of 16 is 2. That would be cubed to the x power. And finally 2 cubed is 8, so you would get 8 to the x power, meaning that our simplified base right here is 8. So because our simplified base is 8, we say that E is incorrect, and we say that F, where the statement says that our simplified base is 8, is correct. So just to recap, that would be correct, 2 incorrects, correct, an incorrect, and a correct. You can go through this as well and just see what the written response is. So correct, 2 incorrects. They're giving the right justification as well. Yep. And yep. Okay. That's good. So we say the solution is correct. Great job. All right. And that's correct.